So this is the Mavic 1 Pro. It's like a 4 years old drone. It's not a very a new one. And I want to go over with you, and maybe we would feel comfortable now to understand what type of sensors it has. So obviously it has GPS, right? Because it needs to follow a waypoint or I don't know what. Let's look at the, so it has a gimbal here, a 3-axis gimbal. It has, two cameras. Why would it has two cameras? Because that one has only one. So those are not cameras, those are ultrasonic sensor, the range sensor, but those are two cameras. An example for that is, assuming there are, those drones are making a lot of wind and it has some sort of dust. It's exactly as if it was an IMU or a magnetic interface. If that thing detects something which is not detected by that thing, they can ignore that. So if I had some sort of momentary blockage on that camera or on that one, then they could cope and they could perform this optical flow without being drift because of momentary blockage. More than that, it can perform stereo. So this drone actually, although being 4 years old, it has those stereo vision cores. You see here two cameras in front, so it has some obstacle avoidance forward. The way it performed this obstacle avoidance is that it had performed some sort of stereo vision and can detect the range, not necessarily in high resolution, but look, it's a big drone, so it only need like my hand size pixel, and in order to decide whether they can go through or not. So maybe a very fine branches or a net could fool that drone. Obviously it did. That one break quite a lot, but if you have like a house or a car or something solid, then those stereo vision, even in a resolution of a few dozen pixels over a few dozen pixels, is sufficient in order to do obstacle avoidance. The same thing with the optical flow, those two stereo here. An ultrasonic sensor is a relatively simple sensor that harness the fact that speed of sound is relatively slow, about 330 meters per second, with respect to the speed of light, which is almost 1,000,000 times faster. So you only need a slower or a low-cost clock to measure the time lapse between the emitting of the sound, the ultrasonic sound, and its echo when it's went back. And by correlating those two, the sound and its echo, and putting it on a scale and measuring the time lapse between that, you get the range. Obviously, the range is subject to distance. Those sensors works only on like 5 to 10 meters. A window would fool LiDAR because light would go through, it's transparent. Or think of a lake or the ocean. So the ocean is very transparent to LiDAR, to laser. But with the ultrasound, it reflects really good. So there are pros and cons, and sometimes you would like to use LiDAR, sometimes you'd like to use ultrasound, and obviously there are the issue of the size and the weight and the price. But it's interesting that it used to be that all of them were ultrasound, and now I think most of the drones are using LiDARs. Let's see what more do we have here. Obviously, we have a lot of heat sensors, and there's a sensor for the battery actually. Other drones, newer drones like the Mavic Air 2 or Mavic Zoom or the Mavic Pro 2, they also are equipped with stereo cameras to the back and sideways and upwards. And to the extreme of that, you can see the I would say amateur graded drone named Skydio 2. It has like 16 camera, performing a perfect, amazing 3D 60 point cloud. allowing it to not just map the entire thing, but also detect the I don't know, point of interest where it needs to follow, and avoid those obstacles along the way, and doing it in an extremely intelligent way. It's kind of interesting that those drones are so complicated because they are very they're being operated by people who want to do sports, who want to do their extreme stuff, and they don't want to actually pilot that. So they are required to do this simultaneous mapping, obstacle avoidance, tracking of their subject or the point of interest. We are moving towards an area, towards this modern time where actually intelligent drones would perform better without a pilot. Fast maneuvering, fast robotics is being intelligent. Fast robotics are being moved from the pilots that control it with the remote control to the intelligence of the drone.